Hello, Algebra 1 students. This is Mrs. Youd. Today I'm going to teach you Chapter 7, Lesson 4, which is about solving polynomial equations in factored form. Please have your journals open to page 221. Factored form is when you have a polynomial and it is written as a product of two factors. For example, if I had x squared plus 2x, this is a polynomial, but it is not written in factored form. In order to write it in factored form, what we have to do is factor out what they both have in common. So in this case, they both have an x in common. And so what you do is you think about, oh, I'm going to divide out an x. And so that means that x squared divided by x is just plain old x. And 2x divided by x is 2. So this is factored form because it is a product, meaning multiplication, of two factors. And if we were to check this and see if this works, x times x is x squared, and x times 2 is 2x. So you'll notice that this is where we started. So this right here is your factored form. The zero product property is whenever you multiply anything by 0, the answer is also going to be 0. This property is what we use to solve a polynomial that is in factored form. So if I take my original factored form here, which is x multiplied by x plus 2, and I set it equal to 0, that means that if this equaled 0, 0 multiplied by anything is 0. Or if this equaled to 0, anything multiplied by 0 equals 0. So what we can do is we can take each individual piece and equal it to 0 and then find out what x could be. Okay? So that means that x could equal 0, or x plus 2 could also equal 0. And if I solved x plus 2 equals 0, I would get x is equal to negative 2. So that means that x could either be 0 or x could be negative 2, and it will satisfy this equation. If we plugged in 0 into the equation, we would have 0 multiplied by 0 plus 2. That does equal 0. If we plugged in negative 2 into the equation, we would have negative 2 multiplied by negative 2 plus 2, which equals 0, and that also works. So that's why there are two possible answers for x, and we're using the zero product property to find those answers. So the roots of the polynomial are the solutions when it equals 0. So if you look at our example that we've been working on, the roots would be 0 and negative 2. If you were to graph this polynomial, so if you were to graph this polynomial up here, the roots tell you where it crosses the x-axis. So let me show you what that looks like. If I were to continue with this exact same solution here, then I know that x is equal to 0, so I'm going to put a point on 0 on the x-axis, and I also know that x is equal to negative 2. So if I go to negative 2, I'm going to put a point there as well. So this shape is a parabola. Parabola, remember, is a U-shaped graph. So that means that I know that my graph is going to look something like this. I'm not exactly sure where that point is yet, but I do know that it's going to be a U-shaped graph, and I know that it's going to cross at 0 and negative 2 because those are what I found as my roots. Repeated roots is when you get the same root repeated. So, for example, if I gave you x squared minus 2x plus 1, and you don't know how to factor this yet, but I'm going to factor it for you, this would factor to x minus 1 twice. So that means if we were to find the roots on this, we would have to take only one of these is equal to 0, x minus 1 is equal to 0, because the other one is repeated. So that means that x is equal to positive 1. When you graph a repeated root, what it's going to look like is this. You'll have it coming down to x equals 1, and since there's only one of them and it's repeated, what's going to happen is that it's going to come down, it's going to touch the x-axis at that point, and then it's going to come right back up. So notice that there's only one root, so it only touches the x-axis once. Whereas over here, there were two roots, and so it crossed the x-axis twice. So all of these problems is just a preparation for the next chapter, which is when we learn how to graph all of these things. So what we're doing is we're practicing finding the roots so that we can graph them later on. Let's take a look at number 1. So if we want to solve number 1, we have it already factored for us. So that means that each individual piece has to be set equal to 0. Because remember, if this equals 0, then it checks out because the whole thing equals 0. If this part equals 0, then it also checks out because the whole thing will be equal to 0. And the reason, remember, is because of that 0 product property. So we're going to take in each individual piece. So x is equal to 0. And I don't need to solve for that because it's already solved for. Now let's do the other one. So x plus 5 is equal to 0. So if we solve for that, we subtract 5 on both sides, x is equal to negative 5. So that means my answer is x can equal 0 or it can equal negative 5. Once again, if we were to graph this, that would mean that this equation would cross the x-axis at 0 and negative 5. All right, let's go ahead and take a look at number 5. I'm going to set this equal to 0, so 2b minus 6 is equal to 0. And I'm going to solve for b this time. So if I add 6 to both sides, I get 2b equals 6. If I divide by 2 on both sides, I get b is equal to 3. Now I will do the other side. So this time 3b plus 18 is equal to 0. So if I subtract 18 on both sides, then I get 3b equals negative 18. Now divide by 3, b is equal to negative 6. So this time my roots are 3 and negative 6. Let's go ahead and take a look at number 6. I'm going to set this equal to 0. 3 minus 5s is equal to 0. And solve for s. So I get negative 5s is equal to negative 3. So s is equal to positive 3/5. Okay, so now I'm going to do the other side. I have negative 3 plus 5s is equal to 0, and I need to solve for s. And you'll notice that in this case, I got the same answer twice. That means that the root is repeated. Even though it doesn't look like it would be repeated up here, the final answer did end up being a repeated root. So that means that my final answer would be s is equal to 3/5. I don't have to repeat it twice because it's the same answer twice. I would like for you to pause the video and try number 2, 3, and 4 on your own. Please pause the video and check your answers. If you got anything incorrect, please see if you can find your mistakes. Let's take a look at number 7. So when we have a square here, what this means is we have x minus 3 and we repeat it. So that means when we solve our answer on this one, we really only need to do it once. X minus 3 is equal to 0, since it's repeated again. So that means that x is equal to positive 3, and this is going to be a repeated answer, a repeated root, so that means we just have the one answer. Let's take a look at number 9. So I have 2t plus 8 is equal to 0. So that gives me 2t equals negative 8, and t is equal to negative 8 divided by 2, which is negative 4. Let's do the other side. So we have 2t minus 8 is equal to 0. So 2t equals positive 8. So t equals positive 4. The reason why I wanted to show you this is that you could say t is equal to negative 4 or positive 4, or it's a little bit easier since it's both the same but just positive and negative. you can shorthand it to plus or minus 4. And we're going to be using this, I'll be using this terminology, the plus or minus, anytime I have a positive and a negative of the same number. Let's take a look at number 11. So on number 11, we have g is equal to 0. I also have 6 minus 3g is equal to 0. And so that would give me negative 3g equals negative 6. So g equals 2. Notice I still have one more piece here. So that means I have a third root. So 6 plus 3g is equal to 0. So that's going to be 3g equals negative 6. So g is equal to negative 2. So this time, this answer has 3 roots. G could equal 0, or it could equal positive 2 or negative 2. So I'm going to use that terminology again, plus or minus 2, because that's a little easier to write. FYI, just so you know, since there are 3 roots this time, this is not going to look like a U-shaped graph. This is going to look like an S. So what this will look like is we're going to cross at 0 and negative 2 and positive 2. So the shape that this is going to look like will come up and then come down and then go back up. All right, so anytime you have 3 roots, it's going to look like an S-shaped graph. I would like for you to pause the video and do number 8, 10, and 12 on your own. Please pause the video and check your answers for numbers 8, 10, and 12. If you got any of them incorrect, please see if you can find your mistake. 13 through 18, we just need to factor the polynomial. And then in the following set of problems, we have to factor it and solve it. So I'm just going to do a few of these with you, and we're not going to do all of them, and then we'll focus more of our time on the ones down below. So if you look at number 13, what we need to do is we need to find something that factors out. So what you have to do is you have to divide out something so that you can factor it. So I have to look first at my numbers, 6 and 3. What is the greatest common factor between 6 and 3? So the greatest common factor would be 3. So we're going to divide out of 3. Now we have to think about how many x's can I take out? So there's 2 x's here and there's 1 x here. You can always take out, so in this case we can take out one of our x's. So we're going to take out a 3x. So it's kind of like the opposite of distributive. You're dividing it out, okay? The opposite of distributive is where you multiply it in. This time you're going to divide it out. So let's take a look at this. 6 divided by 3 is 2. So this will be a 2. And now we have x squared divided by x is just plain old x. Now let's take a look and see what we have next. So 3x divided by 3x is 1. And so then we would just have a plus 1 here. So this is our answer. And I would suggest when you do these problems, you just double check it by multiplying it back in and see if you get what you started with. 3x times 2x is 6x squared, and 3x multiplied by 1 is 3x. And since that does match what we started with, we know we got it right. Let's take a look at number 16. So on number 16, we need to figure out what can we divide out. So let's look at our numbers first, 2 and 7. The only thing we can take out is a 1. So that means I'm not going to bother taking anything out for our numbers. Now let's take a look at our z's. We have 7 here and we have 6 here. So that means we could take out 6 of them. So I'm going to put z to the 6 is what we're taking out. So z to the 6th, and let's see what's left over. So if we take out z to the 6th, we're left with our 7. So I'm going to write a 7. And then z to the 7th divided by z to the 6th is just plain old z. Now we'll take out our the second term. So 2 is left, so plus 2. And now we have 6, or z to the 6th divided by z to the 6th cancel out. So it becomes a z to the 0, which is 1. So that means that this is our factored answer. And once again, if you thought about this going backwards, z to the 6th multiplied by 7z is indeed 7z to the 7th. z to the 6th multiplied by 2 is indeed 2z to the 6th. So you can double check it by plugging it back in. Okay, so that's what we're going to be doing first on these next set of problems. So I'm just going to go ahead and skip ahead and let's take a look at number 19. So what we're going to do first on this problem is factor out what we can. So if I look at number 19 and I look at the two terms, we have 6k squared and we have k. So we can't take out any numbers, but we can take out a k. And so what you're doing, remember, it's kind of like dividing by k because it's the opposite of distributive. And so if we divide out a k, we have 6k squared divided by k would just be 6k. Now we have k divided by k, which is 1, so that would be plus 1. Again, double check this by multiplying it back in and seeing if you get what you started with. So now that it's in factored form, I can go back to what I did on the other page, which is take each individual piece and set it equal to 0. So k is equal to 0. And then I'm going to take the second group. So we have 6k plus 1 is equal to 0 and solve for k. So I have 6k equals negative 1 and k equals negative 1/6. So that means that my answer is k can equal 0 and it can also equal negative 1/6. At this point, if you want to, you could take both of these numbers and plug them back into the equation and see if they work. It might be a good idea to do that on a test or quiz. I'm not going to take the time to do that now, but I just wanted to point that out to you. All right, let's take a look at number 21. So the first step is to see what we can factor out. So since 4 is able to be factored out of 52, I'm going to take out a 4. And if I look at z squared and z, they share a z in common. So we'll take out a 4z. So 4z is going to be taken out. And so let's see what we have inside the parentheses left over. 4z squared divided by 4z will just be plain old z. And then on the other side, I have 52 divided by 4 is 13. So we have 13. And notice that the z's cancel, so there's no more z's there. Okay, now we have it in factored form, so now we can solve it. So 4z is equal to 0. So if I divide by 4, I get z is equal to 0. Take the other side, so we have, or the other part, z plus 13 is equal to 0. So z is equal to negative 13. So my final answers are z is equal to 0 and negative 13. I would like for you to pause the video and do number 20 on your own, just number 20 for now. Please pause the video and check your answers and see if you have any mistakes, see if you can find them. So you'll look, if we look at number 22, 23, and 24, you'll notice that these are not equaling to 0. So what we have to do on all three of these first is move it over. So I'm going to add 72x to both sides. And so my new equation would be 6x squared plus 72x is equal to 0. Now that I have it equal to 0, I can go ahead and factor it. So I notice I can take out a 6 and an x. So let's go ahead and factor that out. Remember, it's like dividing by 6x here and here. So 6x squared divided by 6x will just be plain old x. And then 72 divided by 6 is 12, so that'd be plus 12. And notice that the x's cancel. Okay, now that we have it in factored form, we can solve for x. So 6x is equal to 0. That means x is equal to 0. So we divide by 6. Now x plus 12 is equal to 0. So that means x is equal to negative 12. That means that x could equal either 0 or negative 12. Let's take a look at number 24. Once again, I have it not equaling to 0, so I've got to move my 21p to the other side. Oops, by not adding it, we want to subtract it. So minus 21p. So that means that we have 7p squared minus 21p, and there's nothing left on the right side, so it's equal to 0. I would like for you to finish number 24 and do number 23 on your own. Okay, pause the video and see how you did. If you had any mistakes, see if you can find them. Let's take a look at number 25. A boy kicks a ball into the air. The height in feet above the ground of the ball is modeled by this equation, where x is time in seconds since the ball was kicked. So let's just think about that for a minute. If I were to draw this, so you have a boy who's kicking a ball, right? So the ball is starting on the ground and it's going to come up and it's probably going to come down and it's going to make a nice little U shape here, right? So the ball will be on the ground here and at the beginning. So, and this is time in seconds, okay? And then this will be height here. So how high does the ball go? And we're told that the height is in feet. So now let's go ahead and continue reading. Find the roots of the equation. So that means where is it going to be y equals 0? So it's going to be at the bottom. And what do those roots mean? So we're trying to find out the roots. So we're going to take our equation and set it equal to 0. Negative 16x squared plus 80x is equal to 0. And we're going to solve for that. So we can take out, I'm going to take out 16x, and we're going to have negative x plus 5, and that is equal to 0. So now let's take each part. So we have 16x is equal to 0. So we solve for that, we get x equals 0. And now on the other one, we have negative x plus 5 is equal to 0. So negative x is equal to negative 5. So that means x is equal to positive 5. So that means this point here is 0, 0, and this point here will be 5, 0. So my roots are 0 and 5. So what do the roots mean? Well, that means that the ball is going to be on the ground at 0 seconds and 5 seconds. All right, that's it for today.